All right, guys. So we're moving into our next section. Our next section, we skip over 1.2, just so you know, so you aren't getting confused. We're going to skip over 1.2. We will come back to it, but it just didn't really fit into well with being the beginning of the year and doing our school-based hybrid model. So we'll come back to that at a later time. Okay. So we're going to skip over that, and we're moving on to 1.3 with it, which is midpoint and distance formula. Okay. So we have two different formulas. So in this section, you're going to want to have those two formulas written down so that you can use them when you're solving problems. So our first one is midpoint formula, and I'm in the playlist that I created for you guys. Again, you are going to want to look through all this stuff. I'm making the video. All this stuff is right here for you, so you have access to it. So if you forget what the midpoint formula is, you can come back. You can look up here where it says concept midpoint formula and click on it, okay? So the midpoint formula, it's going to show up here in a second. The midpoint formula is written for you where it says m equals. Okay, so right where it says m equals is the midpoint formula, so it's right here. All right, that is it. And if you notice, all we're doing is we're adding up our two x values and dividing by 2, adding up our two y values and dividing by 2, and we get our solution, okay? So you can also think about this as we're taking the average, so if we have two numbers and we want the average of those two numbers, we're going to add them up and divide by 2 because there's two numbers there, okay? So in our problem that we have here, they give us the points, let's see here, -4, 3, and 2, 1, and we kind of have one of these slider things so that we can move the points around. If you take Q and you move it all around, it'll change it. But I just wanted to make you guys aware of that, aware of the midpoint formula and everything. The midpoint is just the middle point of that line. Okay, it is what it sounds like. So in our little Desmos thing, we can move it all around and see how the midpoint changes and everything like that. Okay, so just kind of moving this around, can play with it. You guys can get on here. Okay. So again, just want to make sure that you understand the midpoint is the middle point, and all we have to do is add up our x values, divide by 2, add up our y values, and divide by 2. And also, if you notice that I'm saying midpoint, so if I'm looking here and I have Q at 2 and 1.5 and P at -4 and 3, my midpoint it's a coordinate, okay? So that's why we have that comma in the middle, all right? We have that comma in the middle separating both of those because our midpoint is another point. So the coordinate, it's going to be a coordinate, so make sure we have both an x and a y coordinate when we're finished. All right, guys. So back to so I just went back to our home screen here, and we're going to go to the first example, and we're going to find a midpoint. Okay, we're going to try the formula for ourselves. Okay, so this one says, what is the midpoint of AB? All right. So to find the midpoint, we are going to use the midpoint formula. All right. So they have the solution here, and I kind of just want to explain things a little bit further. So hopefully you guys have written down the midpoint formula from our last slide. If you haven't, it's going to be x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay. Now we have our two coordinates A and B. Okay. So if you notice, A is at -3, 2, and B is at 4, -2, okay? All right, so when we're doing this, all we have to do is we want to find our x values, which our x always comes first, okay? So you always want to think x before y, all right? So when we do this, we have our x values are 3 and 4, okay? So that's where they're getting this first part of saying -3 plus 4. Now, if we notice our y values are 2 and -2. So that is where they're getting the 2 plus the -2, okay? And since we're adding, we can add in any order we want. So if we did -2 plus 2, if we did 4 plus -3, it doesn't matter. Okay, we're still going to get the same answer. Okay, addition is commutative, so you can add in any order that you want to. So once we add these up and divide by 2, -3 plus 4 is going to give us 1. All right, so that is where they're getting the 1 right here. And it's divided by 2, so that gives us a fraction of 1/2. And then our other part is 2 plus a -2. That's going to give us 0. So 0 divided by any number, all right, will give us 0, okay? So if we have 0 divided by any number, it could be 2, in this case it's going to be 2, it is always going to give us 0, okay? So then, and that's basically because we're saying, hey, you have $2 and you owe 0 people, so you have 0 people to pay back. That's kind of how I think about it, okay? All right. So moving on, we have our fraction of 1/2, and you guys are going to get a lot of fractions, so you don't need to change it into a decimal, unless the problem says to. You can leave it as 1/2. If you have it as a decimal, that's fine too, okay? Just be aware of you might have to change back and forth if you have a multiple choice problem. All right, guys. So we found the midpoint of AB. All right, so we're going to go back to the home screen here. All right, guys, so we're going to do the additional example, and we'll try another one. So for this one, they say find the midpoint of JK, okay? So this time it doesn't give us the coordinates, so I'm going to help you set this one up and solve this one. So for this, we're trying to find the midpoint, and I just want to explain something with the solution, how they have this funky xj and xk. That's just referring to the x and y coordinates for points j and k. So if you have a problem like this and you're not given the coordinates, the first thing you're going to want to do is find the coordinates of the endpoints j and k. So if we look j, and we can count over 1, 2, 3, so it's going to be at -3. We're going to the left in a negative direction, so j is going to be at -3. All right, and then we're going down, and again in the negative direction, so it's going to be -2. All right, so our coordinate for j is 3, -2. Our coordinate for k is going to be, if we look, we're going a -1 direction on the x-axis, so it's going to be -1, and then we are going up 1, 2, 3, so it is going to be -1, 3, okay? So that's where we're getting those from. And then, as you can see, we can find what our x and y coordinates are going to be. So our x is -3 and -1, so that's why we are adding these right here. Our y's are at -2 and 3, that's why we're adding those right there. From there, you can add them, and when we do, we get -4/2. However, when you see -4 over a 2, you should see 2 even numbers. That should be, something should be going off in your head saying I'm not done yet, okay? You're going to have to simplify that. Now on the other side, we got 1/2. We're good. We know that's in simplest form, 1 over 2. We're good to go, all right? Because we have that 1 in the numerator, can't simplify it any further. Now, to simplify the -4 over 2, this is a pretty simple one. All we have to do is divide, and that gives us -2 as our x-coordinate and 1/2 as our y-coordinate. So just to get an idea of what we're dealing with here, if we plot that point on, and it's 1/2, so it's going to be halfway in between, but we're going to be somewhere, we're going to go in the negative direction on the x-axis and up a half, so it's going to be somewhere right in there. Okay, so that is going to be, I'm just going to call it M. That's going to be our midpoint, is somewhere in there, just to get a picture in our head of what we're looking for. Okay, so our math makes sense. We are good to go. So guys, if you have any questions so far, you can ask them in class, or shoot me an email or anything like that. All right, so we're back to the playlist page. We're done with our midpoint, and we're going to move on to the 1-3 concept distance formula, okay? So like I said, doing midpoint, and then we're doing distance. Actually, guys, before we do distance, before we even jump into this, I did want to go over another thing with midpoint, okay? So this is not in like your traditional notes in the playlist. This is something separate. I will put this document on Canvas so that you guys can see it. But sometimes they're not going to ask you find the midpoint. They're going to ask you find the other endpoint of this segment, okay? So I want to do a couple examples here showing you a simpler way than using, complicated algebra. All right, so this is where another part of 1.3, we're finding the other endpoint, and it's going to make sense here in a second. So you're going to see these problems on your homework, and they're going to be worded something similar to this. Okay, they're going to say the coordinates of point T are 2, 3. The midpoint of ST is M at 5, 6. All right. Find the coordinates of S. It tells us what the midpoint is. So that's a big clue. Okay. It's a big clue. It says the midpoint of ST is M. So what it means, it has this segment. We know what the midpoint is. It's a little bit different. We don't have a formula for this one. So just to get that picture in our heads, they give us T and they give us M. Okay, I plotted them on Desmos, taking a screenshot of that. All right, so that way we can get an idea. So what's going on here is we have this line TS. Okay, so this line actually extends out here, and so we're gonna guess, like, this is just a guess, but we're gonna say, hey, S is somewhere out there. All right, so we know what the coordinate of T is, we know what the coordinate of M is. We have no idea what these coordinates for S are. Oh no, what are we gonna do? Okay, so that's just to get a picture in our head. So what I'd like you guys to do is set up these problems the same way. Okay, so I have written down the coordinates for T, M, and S, okay? Right in a vertical line, just like we would see on the segment. T is an endpoint, S is an endpoint, M is the midpoint, okay? So this is how they should be written every single time, all right? And you'll see why here in a second. So to solve this problem, we're just going to use basic addition, subtraction skills right here and figure this one out, okay? So when we're doing this, if we are going to go from T to M, okay, so we are going from 2 to 5. This is what I want you to ask yourself. What am I adding or subtracting? In this case, and this is where you want to think about it on a number line. If I'm going from the point 2 and then I'm going to 5, how far am I traveling? Okay. So hopefully we can figure that out. Pretty simple. We're adding 3. So I'm just going to put a plus 3. Okay. Now, to find the x coordinate for S, okay, so we just added 3. If we're going to go down here and find the coordinate for S, and hopefully we're going to see a pattern here, but right now I'm just going to tell you, all you have to do is the same thing you did above. Add 3. So we're going to take 5, we're going to add 3, and that's going to give us 8. Now we have to do it on the other side as well. So we're starting up at T, going to our midpoint, all right? So we're going from 3 to 6. So again, 3 to 6 on a number line, we got to see how far we're going. So 3, that'd be 4, 5, 4, 5, 6, almost wrote 4. So if we're traveling, we're going 1, 2, 3, okay? So again, we're adding 3 over here. We're going to do the same thing to find the y coordinate for S, and we're going to add 3. 6 plus 3 is going to give us 9. That is going to be our coordinate, okay? 8, 9 is our solution. So that's it. If I find the endpoint, 8, 9, that's the solution. We are done. We're good to go. Now, I'm just going to show you, you don't have to do this, but I'm just going to show you what it looks like on the graph. So if we close this out, we said it was going to be at 8, 9. 8, 9 is 8, and then 9 right up there. That's going to be where S is at. And just, I mean, if we look at it, we can kind of see that that makes sense. We're in a good position using math common sense. S is our answer, okay? So moving on, we're going to do another one, okay? A little bit trickier this time because we're going to throw in some negatives, all right? So it tells us that the coordinates of point A are -5, -3. The midpoint, all right, big clue. Anytime it tells you what the midpoint is, you know you're going to be looking for an endpoint. The midpoint of AC, so our line is AC, is B at 2, 3. So we're finding the coordinates of point C, all right? So again, just to get an idea in our head of what it's going to look like, we have line AB. It's going to be extended out here, and C is going to be somewhere out here. We know what the coordinates of A and B are. C, we have no idea. So we got to figure that out doing the same method. So I have it set up here for you guys. And again, set it up the same way, okay? Just kind of using our common sense where A and C are both our endpoints, and then B is our midpoint. Always put the midpoint in the middle, just like you would when you're drawing the segment. All right, so just be careful. Some people like mess up where they're putting their midpoint and their endpoint. You're going to get the wrong answer. All right, so A is an endpoint, C is an endpoint, B is the midpoint. It goes in the middle for this setup. So to do this, we got to figure out how far we're going to travel from -5 to 2. Okay. This is where the number line is going to come in handy, okay? So if we're on the number line, all right, and we're going from -5, all right, and we're going to go over to 2. So we're going to go to -4, -3, -2, -1, 0, 1, 2. All right, so -4, -3, -2, -1, 0, 1, 2. All right, so we have to see how far we traveled. So doing this, we traveled 1, 2, 3, 4, 5, 6, 7 spaces. Okay. Another way I like to think about this is when we have negatives and positives, is just think how far are we traveling to 0, and then how far are we traveling either in the negative or positive direction. So in this case, we traveled 7 spaces to the right in a positive 7. Okay. Now we got to do the same thing on the other side. Or let's just finish out the left side of the x coordinate. So if we're doing this, we go from -5 to 2 is 7. So then we're going to go down here and we are going to add 7. 2 plus 7 is going to be 9. So our x coordinate for C is 9. And then doing the same thing on the other side, we have -3, all right, on our number line, just to get a picture in our head. And we are going to +3, okay? So we're going to go -2, -1, 0, 1, 2, 3, okay? So -2, -1, 0, 1, 2, 3. How far do we travel? 1, 2, 3, 4, 5, 6 spaces. And we traveled in a positive direction, so we went +6, all right? And guys, I know both these examples have positive numbers in it, but you can also travel in the negative direction, okay? So if you're traveling to the left in a number line, all right, you're going in the negative direction. So for this, we're adding 6. So we come down here. We're going to add 6 again. 3 plus 6 is 9. So our ending coordinate is 9, 9, okay? All right, so when we do that, again, I'm just going to show you what the graph looks like. We're ending up with 9, 9. And it might go off the graph a little bit. I think it is, and that's okay. But just to get a picture in our head is 9, and then it's going to be up here somewhere. That's going to be our coordinate for C, and if we connect it, it looks right. It's in the right position, okay? It's not somewhere over here, over here. We're good to go. It's a straight line. We're good. All right, so our coordinate for C again was 9, 9. So that's just a little shortcut that we have to solve for an endpoint, not the midpoint. All right, guys? All right, so now we are going to move on to distance. All right, so we have the we're on the distance formula in the playlist here, and it tells you what the distance formula is. It looks ugly and messy, I know. So please write this down. All right. Have it with you. You don't have to memorize this formula. You just have to know how to use it. Okay. We'll give you formula sheets and it'll have the formula on there for you. So you don't have to memorize it, but just make sure you have it with you so that you can understand what's going on and where we're adding and where we're subtracting and where we're squaring and everything like that. And we're taking the square root. There's a lot going on here. Okay. So, and then we just also have the slider over here, which is, I don't think it's anything out of the ordinary. It kind of tells you the distance right down here. All right. And as the line gets bigger, the distance gets bigger. Okay. And this is also, I know we kind of talked in the last chapter about a little bit about distance, about running a negative distance. You can never run a negative distance. You can never run negative 5 miles. Okay. You can't do it. Okay. You're always going to run 5 miles. Some people say, well, what if I run backwards? Well, then you ran backwards 5 miles. Like you can't run a negative distance. So in this one, we have to make sure that underneath this square root symbol that we are always getting a positive number. Okay, so we can never take this negative square root. Well, for this class, we can't take the negative square root. So we're always going to want a positive number underneath that square root sign. All right, so let's move on and do some exam. All right, so we are going to find the distance and try it. We're going to do an example here together. So for this one, they're giving you a word problem. Okay, so it looks a little bit tricky. Actually, I think. All right, so I'm going to go a little bit out of order here and do the additional example. All right, first, and you'll see in a second here. So for this one, they're asking us to find KL. Okay, they're asking us to find KL. So when we're doing this, all we have to do is first find the coordinates of K and L. So when we're finding the coordinates, we just have to count over and up. So K is going to be at 1, 3, and L is going to be at 3, -2. Okay, 3, -2. So those are our coordinates for K and L. Now, we have the solution here. And so what they're doing again is that we have those little subscripts of L and K and all that, and it looks a little bit funky. That's okay. They're just referring to that coordinate. All right. So we're going to use that formula. And again, we say K is at 1, 3. L is at -3, -2. So for this one, I do like to label our x1s and y1s, okay, for this. So we have our distance formula there. So what we're going to do is just label our coordinates. So if we start with K, we can call that x1, y1, okay? And then we have our L, which is x2, y2. Because in the formula that you just wrote down, we have square root of x1 minus y1 squared plus x2 minus y2, okay, squared. And when we label our coordinates, it's real simple where they're going. So we know this x1 is going to go right here, and this y1 is going to go right here. We also know that our x2 is going to go right here, and that our y2 is going to go right here. All right. So from there, once we plug everything in, it's going to look like this. So I would encourage you, a lot of you guys are going to try and plug it in your calculator right away. Don't plug it in your calculator right away, okay? You're going to make a mistake with the parentheses, especially if you have one of our, red calculators or anything like that. Even a graphing calculator, it's going to be tough. You're going to have multiple parentheses. It's going to be kind of crazy. So what I would suggest is what they absolutely have on here. Okay, so first of all, do the 3 minus 1, all right, and square it. Okay, and once you do that, put it underneath the new radical symbol. Okay, the new square root symbol. Then go to the other side and do negative 2 minus 3. Square that in your calculator, and when we do negative 2 minus 3, it's going to be negative 5. And this is also where we are going to get a funky answer, okay? Because a lot of you will say negative 5 squared is negative 25. And that would be incorrect, okay? Like I said before, we can never get a negative square root. So you have to be very careful with this one, okay? Anytime you have a negative number, all right, and you square it, it is going to be positive because this is basically saying negative 5 times negative 5, okay? We're multiplying here. Anytime we multiply a negative times a negative, that's going to give us a positive. So it should be a positive 25. So that is something that you can kind of get tripped up on. So just be aware of that when you're plugging something into your calculator that is negative. I'm pretty sure, and we'll kind of go over this when we're in class, but if you have one of those red calculators, it's like the smaller one, what you're going to want to do is plug it in as parenthesis negative 5 parenthesis put the squared key, okay? Because what happens in your calculator is a lot of this will give you 25, but sometimes if you plug it in your calculator and just do negative 5 squared without any parentheses, what it does is it squares, it does this part of the operation where we have, it does this part, it does 5 squared, and then it takes this negative sign and just puts it out in front because it thinks that's what you want done, because order of operations would be exponents before multiplication, because really you're saying negative 5 times 1. So make sure that you are doing it this way and you're plugging in your calculator with parentheses, because if you do it this way, all right, you are going to get negative 25, and that is what we don't want. So just be very careful when you're plugging it in your calculator, okay, guys? All right, so from there, this 4 plus 25, we are on this step right here. All right, so doing that step, that's something where you can just plug that in your calculator. If you just do square root of 4 plus 25, it should give you the correct answer. But regardless, it kind of shows you what it looks like, and so it's going to be square root of 29, all right, which is approximately 5.4. And also, this is where I'm pretty much every time you do some of these problems, you are going to get a decimal, okay, of some sort. You're very rarely ever going to get a whole number. So be careful, especially on the Math Excel. It says give your answer to the nearest tenth. All right, tenth is 1 decimal place. That's why they round it to 5.4. So you have to be very careful when you're rounding your answers. Okay, very careful when you're rounding your answers. All right, guys, so it might seem like a lot of steps, but as long as you follow the steps, you'll be fine. We're going to do another example here that's a little bit more involved. All right, so I'm going to take us back to the screen here, the home screen. All right, so now we're going to go back to that other example, example 4, finding the distance and try it. And this is where it's a word problem, so don't get freaked out, even though I know you guys see word problems and you kind of get a little tense. You're like, uh-oh. So for this, what we're going to be doing is we're just going to be finding the distance, all right, traveled by this ball, okay? So we're just going to be finding the distance traveled by this ball. So it goes from batter to the shortstop is what it tells us in the problem. So a pitcher throws a ball to a batter who hits the ball to the shortstop. If All right, so the pitcher throws the ball to the batter, and then so you just want to read through this. It says a pitcher throws a ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? Okay, so all it's saying is just the pitcher throws the ball to the batter. All right, there are two coordinates on there, and he hits it to the shortstop. We don't know what happens with it after that. Okay, we could assume that it goes to the first baseman. It's kind of tricky that they have first baseman on there, but it doesn't. Okay, so it just travels from the pitcher to the batter. All right, so that's where you're kind of just reading this. All right, and just answering what they tell you. So just be careful with this. All right, we're just answering what they tell us. So from pitcher to batter, and then it goes from batter to the shortstop. Okay, so we have two separate distances. Okay, I'm going to call this distance 1 from the distance to the pitcher to the batter, and then this is going to be distance 2 over here from the batter to the shortstop. All right. So to find the total distance, all we're going to do is add up our distance 1 plus our distance 2, and that'll give us the total distance traveled, okay? So distance T for total, all right? So when we're looking through this, all right, it has it down here for us, okay? So it gives us our coordinates for P, all right, P for pitcher, okay, B for batter, all right. So our pitcher coordinate right there is just going to be 5, 5. Our batter coordinate is at 0, 0. All right, and our shortstop is at 5, 10. So always want to find those coordinates first. So we have those. They tell us right down here, so we can use them right there. All right. So we're going to move on and figure out the distance, that distance 1, okay, from the pitcher to the batter. So when we do that, we have our x1 and y1 that we're going to want to plug in. So x1, y1, x2, y2, okay? All we have to do is plug in our values for x1 and y1. And so we're going to plug in, it has x2, and then it also has all right, so it has our x2 and our x1. So we're just plugging those in. And guys, this is where I'll tell you this. Sometimes we have the formula written as x1 minus x2 squared plus y1 minus y2 squared. It can be written like that, or it can be written like this: x2 minus x1 squared plus y2 minus y1 squared. Either way is fine. As you can see, all I did was I reversed the 1s and the 2s, okay? That's all that happened here. 1s and 2s, 1s and 2s. This way goes 2, then 1, 2, then 1. It doesn't matter. Either one is fine. Pick one way. Go with it. Whatever way the formula is written is fine, okay? I'm just saying it's still the same thing. It might be written in a little bit different order. Don't get too confused. Don't get too worried, all right? So we're going to subtract our x's in a certain order, and then we're going to subtract our y values in that same order using x2 first, using our y2 first, and then our y1. So we plug those in. And again, don't plug this in your calculator. Simplify this part. All right, 0 minus 5 is negative 5. 0 minus 5 is negative 5. Plug that in your calculator. All right, and we're going to get 25 and 25. Remember, plug it in with the parentheses, please, instead of just putting in negative 5 squared, because it'll give you an incorrect answer. All right, because make sure we're not ever getting a negative at this part. Always want to get a positive number. So 25 plus 25, that's going to give us 50. Square root of 50 is 7.1. All right, 7.1. So we figured out the distance from the pitcher to the batter. Okay, so from the pitcher to the batter, our first distance that we have on there, we figured that out. Now we have to figure out what is going to be the distance from the batter to the shortstop. and then we add those two together, and we're almost done. So that is the next part, batter to shortstop. Okay, we're going from the batter to the shortstop. It has batter to shortstop. We're going to label those points, label them as x1, y1, x2, y2. So we're going to plug this 5 in here. We're going to plug this 0 in here. And then we're going to stay consistent and do our 2's first and then our 1's. So plug our 2 in, then plug our y1 in. 10 minus 0. Doing this, remember, don't plug it in your calculator. I'm going to say that every time because I know people are going to try and it's going to give you the wrong answer. So plug this in first. That's all you have to do. Once you do that, we're still looking at 5 squared and 10 squared, 25 and 100. That's from this step, you can plug that in your calculator and get the right answer, okay? You don't have to simplify it down any further unless you want to, okay? So if we do simplify it down, we get 125 and get a final answer of 11.2, okay? So we get our final answer of 11.2. So the total distance the ball traveled, we're going to add that 7.1 that we got from traveling from the batter, or from the pitcher to the batter, and then the 11.2 from the batter to the shortstop. That gives us a total of 18.3 units, okay? Now, the last part of this is we found the total distance on the coordinate plane. However, if you think about a coordinate plane, okay, it is not to size, okay? It's not to size. It's not as big as a baseball field would be. So what they're telling us is 1 unit is 9 feet. So every single little unit that we travel here, that's 9 feet. Travel another 9 units, or travel another 1 unit, it's going to be 9 feet again. Travel another unit, it's going to be 9 feet again, okay? So really, in real life, if we traveled 3 units, we're traveling 9 plus 9 plus 9, or 9 times 3, which is 27 feet, okay? So all we have to do is we figured out that, hey, we traveled, I think 18 point something. All we're going to do with that number is we traveled 18.3 units. All right, 18.3 units. We know that 1 unit is equal to 9 feet. All we're going to do is do 18.3, and we're going to multiply it by 9. All right, and that gives us 164.7. Okay, so they're just taking a little bit further, guys. That's all we're doing here. Okay, so just want you to be aware of that. All right, so that think that is it. Let's go back to the, so we're back at our home playlist homepage here, and we have our concept summary. And all this says is it just shows us the 2 formulas. So this, we have midpoint and we have distance formula. It gives us an example of the midpoint. It gives us an example of finding the distance formula. So it's just on there. It's an easy way to just look back, a little summary for you. In case you forget a formula, you can always look back, okay? So just be aware of that, guys. It's there for you. And then the last thing is going to be the Math Excel homework. So, guys, that's something that you're going to have to turn in. You can work on it in class a little bit. You know, if you have any questions, come into class and we can work those out as well. So that is the assignment that I want you to complete. This was just the notes. So if you have any questions at any point during these notes, I know I threw a lot at you. That's why we have class. Come into class, ask those questions, please, okay? So maybe you might want to make a list if you have a bunch of questions, okay, on how to solve problems. So please come to class, asking questions and everything like that. I'll answer all your questions. If you forget about a question while we're in class, you can always ask later by shooting me an email, and I can make a video and help you out, okay? All right, guys. Well, that is it for 1.3. Hope you have a good rest of your day.